So we're going to take a look at continuing in chapter 2 and looking at inequalities in two variables, as well as the intersection and the union of two linear inequalities. In section 1.5, we talked about graphing linear inequalities in one variable. So we utilized the number line to graph these. In this section, we're going to graph them in the coordinate plane with the x and the y axis. A linear inequality in two variables, instead of being in standard form like ax plus by equals c, we're going to have ax plus by is less than or equal to, greater than or equal to c. So it's going to be different in the way that the question is formatted, but also in the way that the equation is formatted. So we're going to consider the graph of the line x plus y. If I just graph that here, it kind of divides the coordinate plane into two regions. I would have the region above the line and the region below the line. So we're going to think about graphing inequalities in that same manner. A line is going to divide the coordinate plane in half, and then I'm going to be figuring out what side of that line I'm going to shade for the inequality. So if I look at x plus y as greater than 5, such as 0.53, that means that if I take the 0.53 and I plug it in, 5 plus 3 is greater than 5. That's a true statement. So I would shade the entire area above the line. The points that lie below the line would satisfy the inequality x plus y is less than 5. So if I picked a point like 0, 0, 0 plus 0 is less than 5. That's true, and so that would be the shaded area for that. So the first thing we're going to do is we're going to kind of ignore the inequality. We're going to draw the graph of this straight line. Then we're going to make that straight line solid if there's an equal to, dotted if there's no equal to. The next one would be to choose a test point, so a point above or below the line, because it's going to divide the coordinate plane into two regions. Once we choose that test point, we're going to plug it in, and if it's true, we shade the area that contains the test point. So let's graph x plus y as less than or equal to 4. So first, I'm going to ignore the inequality, and I'm going to graph just the x plus y equals 4. I can do this by any number of the ways we did in the previous one, but if you remember, I talked about the easiest way to do it is to find the intercept. So I plug in 0 for x, and if I plug in 0 for x, I get 4 for y. If I plug in 0 for y, I get 4 for x. So I'm going to take my dotted line here, or my complete line, and connect the dots. So in the math lab, you would choose the line with 2 points through it, and you would put your dots there, and it would sketch that line for you. Now it divides it into two regions. I have the region above and the region below. In the region below, anytime you can choose the point 0, 0, we always want to choose that. So I'm going to plug in 0 for x and 0 for y, and I see that that's true. So I'm going to shade the region below the line. If an inequality is written in the form of y equals, but instead of y equals, we'd have less than or greater than, then I can do the same process by finding the y-intercept at another point. What we can do is have a shortcut. If y is greater than mx plus b, you would always shade the above, and if y is less than, you would always shade the below. But this only works when it's solved for y, so I think it would be better to always choose a test point and not try to remember all the different exceptions to the rule. So that's just my personal preference. So here I have x plus y is greater than 0. I'm going to find my two intercepts, and the problem that I run into with the two intercepts is that they're both at the origin. So what I'm going to do is I'm going to take that 0 point from 0, 0, and then I'm going to pick another point for x. So what we could do is plug in 1. So if I get 1 plus y is equal to 0, that would be negative 1, which gives me this point 1, negative 1. So that could also be how you come up with that line. Or we could solve the inequality for y and shade the region above because its y is greater than, or we could pick a test point like 1, 1, and when I plug in 1 plus 1, I do get greater than 0. So this is a way that it's presented differently in the book, but I really just encourage you to use the test point because that's going to work every single time, whereas trying to remember all these different caveats is going to be different. So here, I want to graph y plus 4 is less than or equal to 0. So right away we see we only have 1 part of the equation. So if I solve this for y, I get y equals -4, which we know is a horizontal line. Now do I want to shade above or below that? So I would pick the test point 0, 0. So I get 0 plus 4 is less than 0, which is not true. And then I would try -5. -5 plus 4 is less than 0. So I'm going to shade the point below that line. Let's look at graphing the intersection of two linear inequalities. When I'm graphing the intersection of two things, the pair of inequalities is joined with the word and is interpreted where they overlap. So if I want to graph these two inequalities at the same time, the first thing I'm going to do is graph them separately, and that's just going to help you see how this works. So I'm going to graph both lines. I'm going to choose their test points, and this is what they look like. So once I've shaded, I've chosen my test point, here is what they look like. If I want the and statement, I would put them onto the same axis, and I would shade them with two different colors. So the overlap, which is kind of this purpley area, is the actual solution set. So it's a little difficult. You almost need to graph them at the same time, but have three different colors. So you're going to have the color for the first inequality, the color for the second inequality, and wherever they overlap, you want that to be really clear that that's the solution set. When inequalities are joined by the word or, we must find the union of the graphs of the inequalities. So remember, that's everything that belongs in one group, everything belongs in the second group. So here, we're going to graph those two inequalities. I have a dotted line because there's no equal to. Same thing here, and I'm going to shade them. So I'm graphing them on the same set of axes, but instead of being the overlapping, it's everything except for this white region. So it's everything that's in either inequality. So the answer set is all of this blue, all of this purple, and all of this red. The only thing that's not a solution set would be what's here.